Hello, everyone. My name is Harsha. I'm from AIML. I'll be talking about direct air carbon capture. So, we all know that burning fossil fuels adds carbon dioxide to our atmosphere, which causes climate change. But what if we could just not just reduce our emissions, but also clean up the CO2 that's already present in the atmosphere? What if we could essentially vacuum a sky? So today we're going to be exploring a technology that aims to do just that, DAC or direct air carbon capture. So I'll be talking about what it is, how the main technologies work, and we look at some recent advances and some real world examples. So what exactly is DAC? Simply put, it's a technology designed to suck carbon dioxide out of the air around us. It's different from traditional carbon capture, which is installed at a source like a power plant chimney to catch emissions as they are released. But DAC works with regular atmosphere, so it can be built anywhere in the world, and it'll help you clean up decades of CO2 which have already been emitted. So there are two primary methods for capturing CO2. The first is called solid DAC, which uses solid filters that act like chemical sponges. And the second is liquid DAC, which uses a chemical solution to wash the CO2 out of the air. So let's look at both of them. In solid DAC, huge fans pull air through filters, and these filters are coated with a special chemical called a sorbent. This sorbent has a high affinity for CO2, so as the air passes through, the CO2 molecules get stuck on the filter surface. And when the filters are completely saturated with carbon dioxide, they are moved into a container where they are heated. And when they are heated, the bonds break and CO2 is released as a pure gas, which can be stored and the filters can be reused again. Next, we have liquid DAC, which it works a bit differently. Air is sent into a device called an air contactor, and the solution commonly used is potassium hydroxide. This solution is like a really powerful absorbent. It chemically reacts with the CO2 in the air, and the so once the liquid absorbs all the CO2, it's pumped into a second piece of equipment called a reactor. Here it's heated and CO2 is released as a pure gas. So the solution, potassium hydroxide, is regenerated and it can be cycled back to the air contactor to capture more CO2. So the biggest challenge when it comes to DSC is that it's very expensive, but the recent advances are changing the whole game because scientists are creating new materials which release captured CO2 with much less energy, and there are new facilities being built in 2025 to design the which are designed to like fully power renewable energy like solar or geothermal energy. And companies are moving away from massive factories, uh, and they're moving towards small units, modular units which can be scaled up, uh, which can ultimately reduce cost. So coming to real world examples, so this is already implemented in a place in Iceland. So a company called Climeworks is they have a solid DSC facility, and they capture about 4,000 tons of CO2 from the air every year, and it's powered completely by a geothermal energy plant. And the CO2, so you might ask what happens to the captured CO2. So that's mixed with water and injected deep underground into rock formations where it automatically mineralizes and it's permanently locked away for forever. So this is the facility in Iceland. Yeah. So these are what we can do with the CO2 once it's captured. So one of the main things we do is something called sequestration, which is injected where the CO2 is injected deep underground. But One of the most exciting applications is to actually reuse this CO2 to create products. Like, for example, we can combine the CO2 with green hydrogen to create aviation fuel. And when a plane uses this fuel, it's just re-releasing the carbon that was already captured from the atmosphere. So in a way, it's creating like a closed loop. So there is no net increase in the emission of CO2. Yeah, so these are some of the ways we can utilize the captured CO2. Yeah, so in conclusion, DAC is a very necessary tool in our fight against climate change. It's moving from a futuristic concept to like a real world solution. And technology is very rapidly bringing down the costs. With that being said, it does not absolutely replace the need for us to reduce our emissions. It's more like it'll assist us in our goal to create a more sustainable future. So it'll let us clean up our past, and it's absolutely necessary in creating a better sustainable future. Thank you.